All right, good morning everyone. I will be talking about some of these localized outbreaks we see in almond orchards. Janandra also talked this morning about invasive exotic insect affecting almond. We also got a new disease this year affecting almond. You may have heard about it, the red leaf blotch. So I'll summarize all of this information. Part of my work, we're an extension network, cooperative extension. I'm the plant pathologist based at Kearney, and I work on a regular basis with farm advisor to conduct farm call, farm visit for field diagnostic. My lab also process on average maybe 200 samples per year of odd things, whatever growers PCA do not recognize in the field. Sometimes we'll get to my lab for diagnostic. So we tend to see a lot of things. We sort of at the forefront of field observation, new disease discovery based on these diagnostic services. And so today I will provide sort of an overview and summary of what we've seen either in some specific region of California or statewide as new problem or localized problem. But first I like to touch on some basic principles of plant pathology. One basic paradigm of plant pathology is that disease triangle. And basically what that disease triangle says, for a disease to happen, you need three factors to be sort of all reunited here. And first is, having a susceptible host. And within almond alone, we know there are differences in the susceptibility of cultivars. So having a susceptible host is one first factor for disease occurrence, but this needs to be combined with an environment that's generally conducive, right, for disease. For example, in California, we know that wet springs are leading causes for disease outbreaks. And finally, we need the pathogens to be present in a specific area. So we need really, in summary, those three factors: susceptible host, the presence of the pathogen, and a conducive environment for disease to occur. And so this is important. This is usually how we try to work our way towards disease management, either eliminating the pathogen by appropriate fungicide sprays, improving the environment by eventually improving air circulation, or working with a host that eventually is more resistant or tolerant to a specific disease. So disease and pest emerge, and how this happen in general. It may be related to the intensification of agricultural practice. I mean, the almond industry is really widespread in California. It's sort of this large orchards area throughout the Central Valley that are sort of nearby each other. So if a new disease is introduced, you may think that it will spread quickly. Climate change, all this heat wave, these wet years that we're having are also sometimes responsible for the emergence of new problems. But then, probably more importantly, is the global movement of plant material. Any plants moving into California and not going through a normal process of quarantine eventually could lead to pathogen introduction. And that's probably the case for red leaf blotch. Could be also the case for the Carpophilus. But also sometimes the expanded geographical distribution of the host also can lead to problem. If we were to grow almond in Washington state, eventually we'll have additional disease that we don't see here. But basically all these factors, the climate, the intensive practice, and eventually pathogen introduction, all can lead to sort of a shift in the disease we're seeing. It's not anything constant, that sort of a disease complex or situation that we are, all can eventually evolve and change with time. And California in the past years has suffered many climatic events where we can definitely think as California being at the forefront of new disease emergence. So you guys all recall the drought, and this sort of continue with major heat wave. Heat wave usually lead to plant stress, and plant stress eventually lead to more disease. 2017, 2023, you guys recall this extreme precipitation event, and all these are basically conditions that can lead to either localized or statewide disease outbreak. I mentioned intensification of agricultural practice, due to eventually labor shortage, but we see, our cultural practice being more and more mechanized. We eventually have some intensive pruning in our almond orchards. So some of the density may be high, or eventually at higher density, leading to higher humidity in orchards and conditions that are more favorable for fungal disease. We sometimes work with clonal propagation materials. So if one clonal line is susceptible, meaning all plants will be susceptible. And we tend to also have large inputs of water and nitrogens also that can create conditions that are favorable for pathogens and disease expression. So going over this disease, I will be talking about roots, canker, limb, twig disease, and so on, and fruit disease. But first, I want to mention the canker disease and the rise of canker disease. As an extension pathologist again, and as the leader for this diagnostic service that we are providing to the UC Extension and farm advisors and PCAs, to that day, canker disease remained the #1 farm cause in my lab, so these are extremely widespread. They are often associated with mechanical harvest and pruning and trees that are stressed. But among them, there are two canker diseases that prevail in orchard. One is Ceratocystis canker, and the other one being band canker, or the Botryopsferia canker. You may have been aware of this sort of outbreak of aerial Phytophthora in previous year when we had this, again, atmospheric rivers going through California. And then some of you also locally may have heard about this Canoderma problem, this wood decay pathogen fungi affecting young trees anywhere from Fresno, Madera, and Merced County. And so I will go over some of these diseases. Again, when we talk canker disease, usually we are mentioning those diseases that affect the trunk, the large limbs and scaffolds. They cause discoloration in the wood. They cause profuse gumming. But in general, they are the first leading cause of tree death, right? So canker disease in a young orchard is bad news. A tree most likely will die, and then all the effort of trying to establish in orchards are becoming vain, right? Ceratocystis canker, I mentioned, basically anywhere in California, in any tree suffering shaker injury, you will be likely to see Ceratocystis canker developing in an orchard. So it's pretty much ubiquitous. We're not exactly sure where this pathogen is originating from, but what we know, it's only happening in California. We have many almond producing regions in the world, but that disease is unique to California. So it's probably likely to occur in natural environment and making its way to almond orchards. Of course, the inoculum is present in almond orchard, but yeah, again, any trees that will suffer shaker injury is likely to suffer this Ceratocystis canker. It's a unique disease, a fungal disease, in a way that is spread by insect and not by rain. And this is a pruning cut. It's very interesting to see how much bugs are attracted to these fresh pruning cuts. And so that's how the disease move around, right? Those bugs or Drosophila fly, they will collect the droplets of spores from these fruiting bodies and move it from a tree to a fresh pruning cut. And so that's how Ceratocystis is going around. And so talking about localized outbreaks, sometimes to the scale of an orchard, but we've been in situation where grower made this early pruning somewhere around like October, November, and here in that case we've seen all this, every cell in that graph is a tree, and all red cells are a tree affected with Ceratocystis canker. So there are scenarios of maybe not having done your pruning at the right time where things locally in your orchard could sort of outbreak. And again, that was one case of Ceratocystis canker really badly affected this orchard, probably associated with early pruning. Again, this disease moved with bugs and some of these fruit flies. So it's possible there's a lot of activity around October, November, especially if you have grapevines, vineyards, and maybe apple orchards in the area. And that could explain why in this specific situation we had sort of a local outbreak of Ceratocystis canker. Band canker, you probably have all seen it, but that's the disease that's characterized by these gum balls going along the circumference of the trunk. The disease develops at cracks, and usually these cracks are the result of highly vigorous tree, either by this choice of cultivar and rootstock combination, or just because trees are receiving, important amount of nitrogens and water, and so they grow quickly, and these cracks are now sites for infection by this Botrytis fariaceae pathogen. So my colleague Themis Michelidis was the one to point out as sort of an increased occurrence in recent years, and we could speculate why do we see again so much band canker more than past years. We know that wet spring could lead to outbreaks. We know that trees that are really pushed intensively or that are really vigorous also could lead to more cracking and more disease. But part of Themis Michelidis' work was also to eventually link this Botrytis fariaceae band canker outbreak with contaminated plant materials. So there are other situations where not only the weather, not only the environment conditions or the introduction of a pest can lead to disease outbreak, but eventually working with contaminated or infected planting material. You are all seen that, all the orchards where a tree falling down following a wind event. And here in those sort of cases, these are usually associated with hot rot or wood decay. And these diseases have been associated with basidiomycetes fungi, mushroom type, these bracket mushrooms, and they've always been sort of considered secondary, particularly secondary to crown gall infection. But in recent years, this sort of Ganoderma has been quite a bit of a concern, where many relatively young orchards, 8-9 years, eventually sometime younger, were also suffering this hot rot and wood decay. So you can see on the pictures what the inside of a trunk look like, but basically in these 9 years old young trees, infection is already quite widespread in the trunk, leading to the tree breaking. So we're not exactly sure what's going on with this issue, why it has been so prevalent in recent years. But that is something that is sort of investigated at UC Davis. But it's possible that suckering could be an entry site, or the shaker damaging the roots could be leading to infection. But something that also has been a concern lately in California almonds. I wanted to mention silverleaf. It's very, I would say, quite rare disease, but when the few times I've seen it, 100% of the tree were affected, right? So silverleaf, it's caused by that Chondrostrium purpureum mushroom. You can see it on pictures out there on the right side. The disease is recognized because leaves have a lighter color. You can see light colors leaves, silver-rich type leaves, and the normal leaves in these pictures. A very interesting disease. The fungus grow really fast, and you will find canker all the way up into the scaffold branches, all the way down into the rootstock. So really fast-spreading fungus pathogens. And then again, usually we tend to see it near Gustin, Stanislaus County. That's usually where we got the call. But again, in situation where you see 100% of the trees affected, again, you may question here, in that case, the quality of the planting material. Following up on the canker, there's another rare canker, but that seems to be more and more prevalent in California. It's not well known to growers. It's sort of another hull rot, where infection initiates at the hull split, but then from the hull split, the pathogen will move into the peduncle, leading to these internal canker inside branches. And so this, again, is not exactly very common, but when you found it in an orchard, almost every other tree can be affected. That Neoscytalidium canker, we can speculate why in some situation it's really prevalent. We know that the pathogen really like warm temperature, is doing great at 95, 90 degrees. Fahrenheit, and so with a tendency to see really warmer summer, that could explain why Neoscytalidium has expanded in California. But it's also sometimes the result of a specific location where you have old walnuts, and we know that that pathogen is causing the branch wilt disease on walnuts. So if you are almond next to walnut, and this walnut have canker disease, you could be more exposed to an outbreak within your orchard of Neoscytalidium. So Phytophthora, I've been talking quite a bit in these past years of Phytophthora. We had very wet years. We had atmospheric events that led to really, quite significant Phytophthora outbreak, both in pistachio and almonds. And we've been, talking and publishing about this information. But in general, in the last 10 years, we see a lot more and more Phytophthora. So we can ask ourselves, why is this Phytophthora becoming so important? And it's for sure true for pistachio, but more orchards are being planted in marginal soil. This soil have high clay levels. They may have been hot pans. The water infiltration is becoming poor, and that can lead to more Phytophthora problem. Remember, Phytophthora love water. It's usually an issue where you use surface water. It's not a pathogen that has been detected from well water, but nevertheless, over-irrigation can lead to Phytophthora problems pretty much anywhere. And again, you all remember the flooding events in the past years, this atmospheric river. All these issues have led to sort of more and more cases of Phytophthora here locally in California. So again, just a few words about the biology of these fungi, but they are like water molds. They basically adapted to live and swim with water. They have zoospores that can swim. They're not exactly fungi, they're more like, again, water molds. Phytophthora is, again, a disease that loves standing water, and so the disease will occur when saturation of water has occurred in an orchard. And then we tend to distinguish two types of decline. One that's usually slow is when only the roots or the feeding roots are affected. That's like the root rot phase of Phytophthora. But sometimes we see a very quick decline, and that's when the root crown is affected, girdle, and trees are collapsing quickly. A few words on the biology, and it's sort of, again, you're very unique to almond. We know that Phytophthora are soil-borne pathogens that generally affect the roots, causing root rots. And they basically have this overwintering structure. They are called oospores. They live in the soil, and then when the soil is saturated, a sporangium germinates, releasing then ascospores that can move through the pore of the soils and get to a root and infect the roots. But there's really a unique situation in almond where this oospores or this pathogen can also affect the areole part, the trunk and scaffold of almonds. And that's because these oospores, usually during harvest, can be picked up from the soil, blown up into the air, and then they will sort of land back in that pocket, in that tree crotch, in that junction between the scaffold and the trunk, sitting there and waiting for humidity or water to allow for spore germination, and then causing areole canker. So it's sort of a unique disease here in almond where Phytophthora can cause, again, both root rot as well as these areole cankers. So this is an example here in pistachio, but of a root rot. You have control plant non-inoculated with Phytophthora, but then you see young plants inoculated with Phytophthora, right? Phytophthora has this capacity to rot and decay the roots of a tree. And so in almond, the Phytophthora disease are actually quite common in young trees, young orchards. We've seen blocks with 10-15% infections in situations. And usually, of course, the risk is there if you're using surface water. But a lot of times, sometimes the issue is related to a poor planting situation where the bud union is below the soil line, and you're really highly susceptible. Almond cultivar will then pick up the disease. Over irrigation is classic. A lot of time when I see Phytophthora is that emitter from your drip line stay at the base of the trunk for too long, creating this sort of water accumulation at the base of the tree. And so it's recommended to move that drip emitter away from the trunk after the first year of planting. We have two sort of species that were only reported recently affecting these almonds, and those are Phytophthora nidarocereae and Phytophthora mediterranea. I like to point out foamy canker when I talk about Phytophthora because for a long time we've been speculating what is foamy canker. It is my conclusion that foamy canker is sort of a response to the tree to an infection of Phytophthora. Okay, sometimes you don't detect it that easily because the infection may be below ground or so on, but there's been many situations where we've seen those tree foaming with this bright orange color on the trunk in orchards that were affected by Phytophthora. So this is the aerial phase of Phytophthora canker in almonds. Usually infection initiated in that sort of pocket there at the tree crotch. Here we see different species, usually Cactorum, Phytophthora cactorum or citricola, but they lead to profuse gumming again around this large scaffold. And that's what we call the aerial Phytophthora. Similarly, in those orchards, we also seen a lot of foaming canker occurring, and so that's how we can say, relatively confidently that there is a direct connection or relation between Phytophthora infection and foamy canker. So when it comes to Phytophthora in almond production, it's very important to sort of get a sense of what species you're dealing with. There are multiple species affecting almonds. I've mentioned a few: Nidarocereae, Mediterranea, Citricola, Cactorum, and Syringe. But here, the species type you may have in an orchard matters because they all have different biology, and that biology can really affect sort of how a disease will develop in an orchard. And this is a good example where some of these new species that seems to have emerged in recent years, Nidarocereae and Mediterranea, they do just great at anywhere 90 degrees Fahrenheit, 99 Fahrenheit. So we can really sort of imagine here that really this warm and more and more warming weather and heat waves could eventually be selecting this Phytophthora species in our soil. On the other hand, Phytophthora syringae, which is more responsible for aerial Phytophthora, is actually a species that do not like warm temperature. It's so that does okay around 60, 70 Fahrenheit, but above that the pathogen will die. So very important in terms of trying to put a diagnostic in your orchard of what's going on in terms of Phytophthora to also eventually get a species name. So this is just a few years ago. You remember the flooding, the atmospheric rivers in California. There's been several events, 2017, 2023, where we have these sort of major events of water pouring throughout the Central Valley and flooding our orchards here. So we may question, what are these flooding leading to in terms of disease, but anytime an orchard is flooding from a stream, from flooding from a stream or from a river, this is a likelihood for this Phytophthora pathogen to be introduced in orchards. We've seen in pistachio orchard new species actually of Phytophthora coming in orchard following a flooding. In California almonds, what we've seen typically following a flooding is just additional Phytophthora infections, where you see the gumming being produced on the trunk, the canker and discoloration around the root crown and tree collapsing relatively quickly. So really one major outbreak that we faced following those super wet winters, a heavy rain in December, heavy rain in January and so on in February, I believe that was 2023. We saw this outbreak of a disease that was known as a pruning moon canker from Phytophthora. We can also call it aerial Phytophthora. But here in that unique case, the disease is caused by Phytophthora syringae. You can see the disease and the gumballs really initiating from a pruning wounds. That disease is actually, or the gumming pattern is quite unique. I think the disease is easily recognizable in an orchard. You have flashy red and orange colored gumballs. It tends to develop really quickly. And again, in this orchard, we're talking about outbreak because we got called from across the Central Valley. And in this affected orchard, we had anywhere between 10 and 75% of the trees that were affected with this aerial Phytophthora. And nonpareil specifically seems to be also highly susceptible, such as Shasta, Ulrich, Monterey, and Bennett Hickman. What was very novel this past year, and why a lot of us were scratching our heads, is we saw this Phytophthora infection initiating at twigs. And that was really never ever reported, but we could associate this gumming on this young twig with the Phytophthora, and basically the pathogen somehow makes its way through these relatively green twigs and move from there into the larger scaffold, causing this substantial gumming and infection and cankers in larger branches. Again, more pictures where you see infection initiating from a twig and then from the twig moving into a larger branch. So again, Phytophthora syringae, we'll see it probably every decade or so. I mean, I'm not sure if we're getting an El Niño year again. That could be another year for Phytophthora syringae, but something that was reported in the 80s, then in the 90s. But yeah, something that will pop up in orchards once in a great while. It may, we've seen it was associated here with twigs, but it may happen if you have prune your orchards just before a major atmospheric event. Pruning wound can be susceptible for up to 4 weeks. We know that's a pathogen that also favor a relatively cool temperature, but expansion of this cankerworm infection occur can happen very quickly. However, again, the optimum temperature for growth for this Phytophthora syringae is anywhere between 59 and 68 Fahrenheit. And so that pathogen or a canker expansion will stop at about 73 degrees. And then even the mycelium of this pathogen will die under hot summer temperatures. So you may see infection developing in the orchard around February, March, or April, but then, by June, that fungus, that pathogen will die naturally. So, do I need to control Phytophthora syringae? Eventually, if you see symptoms developing early in the season, you're cutting the gumballs in February, it might be wise to have either a phosphate, potassium phosphate application or so on to try to have the product reaching out and slowing that canker expansion before June comes. But anyway, if you're detecting that later, know that this pathogen will die naturally in June. My colleague Jim Adoskavich has done a lot of work to show products that are effective for Phytophthora. We have interesting new molecule, in particular oxathiapiprolene with the product Arondis. This can be applied through the drip and allowed to sort of clean the soil from these Phytophthora propagules. But in general, Phytophthora disease management again comes to proper water management, avoiding puddles at the base of the trees, thinking about when it's time to remove that emitter from the base of the tree to again avoid water accumulations. Of course, we have different rootstock, more or less tolerance to Phytophthora, most susceptible almond, then peach, and then most tolerant rootstock being plum. Following canker and branch and trunk disease, now I would like to move into talking about those outbreaks that may more affecting your flowers or fruits in almonds. We're talking about spring and summer disease. They sort of all follow this, importance associated with some phenological stage. We have disease of the flowers, we have disease of fruitlets, and then of young fruitlets, and then we have disease that tend to develop later in the summer, right? For all these diseases, again, colleagues, Jim Adoskavich has done great work about summarizing the best timing for fungicide application for all these diseases. This is extremely valuable information with all these plus indicating this is your best timing for spray. But if maybe traditionally where time and finance were good with almonds, we were eventually maybe putting, 6 sprays out there, but with sort of lower price of almonds, growers have eventually reduce their numbers of sprays, eventually coming down to sometimes 1 or 3 sprays. And with sort of the skipping of critical sprays, we've seen also locally some sort of, in some orchard, localized outbreak from having missed eventually a critical spray following before rain. So this is the case for brown rot or the blossom blight. It's an old disease of almond. It's very well known, but there have been several cases eventually related to the skip of an important spray, where we've seen that was this past year actually quite a few severe cases of monilinia or blossom rot. These tend to be happening in cultivar that are susceptible. We've seen it quite a bit in wood colony, but also in orchards with like butte almond trees. Again, it's a disease that will happen when you have wet springs, but the accumulation of this canker in orchards will lead to an accumulation of inoculum, and so when the problems start to presents itself, it can eventually reoccur. So that's something that we have seen in past years, sort of coming back, most likely from skipping some sprays. But again, it's a disease that will be mostly prevalent if you have a relatively warm spring, 58 Fahrenheit at least of temperature with some humidity, wetness from rain or fogs. And again, so, thinking of disease management in this sort of situation, you need to also understand your orchard history. But if you have one of these cultivars that's highly susceptible to monilinia, if we have a wet bloom, if we have a wet bloom and with relatively warm temperature, then eventually in this situation you may consider having two sprays to manage something like blossom blight. There are dry years in Kern County where I'm pretty sure you could skip a bloom spray and not having to deal with blossom blight. But basically, knowing your host, knowing the susceptibility and the specific weather condition that you're maybe telling you, how much spray may be needed to manage such disease. There are years where you won't see the blossom rot, you won't see monilinia, but then you might see another one here. In those cases, that's the botrytis or the jacket rot. So although I just mentioned monilinia like relatively warm weather, 60 degree Fahrenheit, botrytis on the other hand like cool springs, right? So if you have a spring that's still wet but temperature are cold, this will be the kind of situation where you see this botrytis or jacket rot coming into your orchards, right? I mean, again, fungicide control can be done with your conventional full bloom and petal fall. But if these are skipped again, and then if you have a cool and wet spring, then you may see this disease. It's not often easily recognized by grower because you don't see it a lot. But we've been to some orchard where trees can be really affected. You have a picture that's from colleagues in Portugal where you actually see a lot of sporulation of this pathogen on young nuts. But again, there are localized situations where botrytis also can become a problem. Now I'll give a few words about anthracnose. Again, it's a disease that, it was quite a big issue in the 90s until our colleague Jim Adaskevich did the fantastic work to understand the biology of this disease and come up with a good fungicide application to manage anthracnose. But again, anthracnose is one of these diseases that at a local scale could become a major problem, and that again will depend on what cultivar have you planted in your orchards. And we've seen a situation. It may be more I've seen this in Spain or Portugal where they use highly susceptible cultivar and they tend to have wet and warm spring, and anthracnose become unmanageable, right? So there can be situations where also anthracnose can be a severe problem in some orchards. It's a very interesting pathogen. It can be aggressive to pretty much all tissues and all organs in an almond. It can affect the flower, the twigs, and the fruits. Anytime there is rain, that means the conditions are favorable for anthracnose. So these are pictures where the disease is affecting leaves. Now the same pathogen, Colletotrichum, can affect the fruits. Usually the diagnostic here is from this abundant gumming, but you will see some form of orange sporulation, masses of spores from Colletotrichum that can help with field diagnostic. And then eventually, in very severe cases, then the same pathogen can also lead to twig dieback. Okay, so a very sort of a complete and aggressive, pathosystem or disease where flowers, young twigs, and fruits can be affected by the pathogen. So here's a slide from Dr. Jim Adaskevich, but why we understand that in some situation, anthracnose can be an issue. This image illustrates the severity or the intensity of disease that may be occurring according to wetness and temperature. Again, when we have temperature close to 25 degrees Celsius and a wetness period of around 60 to 72 hours. These are the perfect conditions to lead for anthracnose disease outbreak in almond orchards. So for management, again, one thing to remember with anthracnose, your tree may be susceptible to it anytime there is rain. All tissues of almonds will be susceptible, and so if you remember that timing of fungicide application, where pretty much every timing is actually a potential timing of application of a fungicide to manage anthracnose. And so there have been situation here with Roger Duncan in Stanislaus County, where we came to an orchard and growers had a really hard time. He was spraying for anthracnose, but really could not get on top of this disease. And that sort of a picture here illustrates in blue columns the rain events, and in red the various fungicide treatment. And it appeared that basically eventually only one rain was not covered from the fungicide, and that was enough to lead to, again, an outbreak within this orchard of anthracnose. If you're also heavily suffering from anthracnose in your block, we also recommend to remove all this dead wood, as this dead wood is actually sources of inoculum for anthracnose. Bacterial spot, I think here we can talk about a disease that recently emerged in California. Again, Jim Adaskevich reported it for the first time in 2013. It seems to be relatively, sort of specific to a certain cultivar. Fruits seems to be highly susceptible, but again, that's kind of a disease that can be, of significance. Again, depending on the cultivar you're growing, and again, depending on your weather during spring, if you have high moisture and warm temperature, this will be typically favorable for infection by bacterial spot caused by Xanthomonas. Alternaria, I wanted to put a few words, can't exactly talk about an outbreak, whatever. Alternaria is widespread in almond orchards. It's generally a late disease that comes later in the summer. It's a disease that's favored by high humidity in orchard, including dew, when the air is stagnant. And typically, fungicide in May and June can help control this disease. But there have been situations, again, these were cultivar dependent. Some self-pollinated cultivar seems really highly susceptible to Alternaria leaf spot, and we've seen few localized orchards where disease was really bad. And so in that case, that can be a problem. You have a lot of black spots on your leaf, but this will lead to an early defoliation of the trees, and early defoliation means less reserve being put back to the tree, less carbohydrate going back to the tree. And so overall, this can weaken the trees. And so, of course, in this really highly susceptible cultivar, spray are definitely required. But there's been such situation, the same self-pollinated cultivar, where this is at this point speculation, but we've seen these orchards suffering heavy Alternaria infections. Tree eventually defoliates. They really, they store less carbohydrate. There's complete depletion, and so basically, when tree push the following years, we've seen this sort of erratic bud break that eventually, again, could be infected with a heavy infection in previous years. Almond leaf scorch. Just a few words here. Again, it's a rare disease, but anyway, there are years, and we're not exactly sure what's going on where we see localized outbreak. That's always the case, or often the case for the northern Sacramento Valley. But I was just in touch with Brent Holtz in San Joaquin County. He's seen a lot of almond leaf scorch this year. Again, the disease is caused by a bacterial pathogen that moves around with those sharpshooters. Symptoms are very typical, as you can see, this sort of necrotic and sort of yellowing sort of margins. But again, this year and 2020 including seems to be years where we see localized outbreak of almond leaf scorch. This could be related to winter and summer temperature. We tend to see it more when we had a mild winter and a warm summer. But again, there are some cultivars that are particularly susceptible, Sonora, Winters, and Wood Colony, where eventually, locally, you can see, again, plenty and numerous trees within an orchard being affected by this disease. Now let's get into red leaf blotch, probably here the main concern at this time for the industry. The disease just appeared basically this year in California. It's new, it's invasive or exotic disease to California. It's caused by the fungal pathogen Polystigma agmidillum. And first detection in California, but we knew this disease from being very common in Spain, Portugal, or the Middle East. It's a very common disease of almond in Europe, but we detected it for the first time here in California this year. So quite a concern for the industry, and I would like to go over symptoms so we'll all understand what we're dealing with. When the first symptom popped up this year, exactly at that stage, this sort of yellowing spot, PCAs and growers were confused. We could be dealing with some phytotoxicity or some herbicide drift or something. So there was a little bit confusion there. So symptoms are basically characterized by this yellow blotching in May. But as you move into the season, you will see this bright orange color and some sort of a dark center necrotic tissue within leaves. Again, it's a disease that only affects leaves. It doesn't affect the nuts or it doesn't affect the twigs. But as we progress within the season, you see again, that's in June, several blotches within leaves. And then again, what was actually kind of of concern is, we had some orchard where basically every leaves on every tree was affected by this new disease. Again, easily recognizable, and specifically if you're looking at it in June, bright orange blotches and some necrotic brown tissue within the center of this necrosis, easy to recognize. And then as we move into July, then you find more of a necrotic, sort of crispy leaves around mid-July. That's in late August. Well, now we're talking definitely about necrotic tissue. And here are some of the picture and why this disease may be of a significant concern. This one of these orchards where tree, by the time we got into August, that completely defoliated, right? So this means that eventually tree may try to push new leaves, but basically in general, this comes at a high energy cost for the tree, and if these events are repeated, eventually less carbohydrate again will be stored, which come again at a significant energy cost, reduced photosynthetic activity for these trees. I've been talking to colleagues in Spain, and so they evaluated that such situation could lead up to 30% in yield decline. So just a quick summary of what happened. First detection, I guess that was actually from Cameron here. We detected it at the border between Merced and Madera County. And then since then, we looked around, we worked with Farm Advisor, got call from either PCA and Farm Advisor, but so far this is the current distribution. It was pretty much distributed all the way from San Joaquin County to Fresno County. We haven't got any call from Kern or the Sacramento Valley, but we're expecting the disease might spread there shortly. So not really sure how he got here. There's a lot of speculation out there. I mentioned new disease or pathogen being introduced with plant material. It's possible that some people decided to bring material from Spain, wanting to test a new cultivar and then imported the disease. So something to keep in mind to avoid bringing plant material in the States. But also what seems to be another concern for the industry is like our main almond cultivar are highly susceptible, and we're talking about Ulrich, Butte, Carmel, Fritz, Independence, Monterey, Nonpareil, Padre, Shasta, and Wood Colony. So we are currently put a proposal together with the Almond board to address this issue, and of course one strategy in our research objective will be to test the best timing and the best product for disease management. But talking with research colleague in Spain, it seems like the management for this disease will, or the best timing for fungicide application for this new disease will be very similar to scab and short holes. So that means petal fold 2 weeks and 5 weeks. So let's say if you have a good program for the management of this other foliar disease or like shuttle and scab, then the expectation is that you will cover your red leaf blush. So if he was found in your orchard this year, remember disease management come also with a knowledge of orchard history. If he was found in your orchard this year, we highly recommend that you take action next year with a pedal full spray and 2 weeks at least, and then if rains continue, eventually go for 5 weeks. It was mentioned that anything that can help removing the leaves from the ground may be useful. However, this is a little bit more difficult to implement, especially on the large scales. But something about the biology, this fungus will survive on the leaf litter on the ground, right? So that's how next year, spores will emerge from this leaf litter, from these fruiting bodies, and infect the young leaflet just around pedal fold. This is another picture from Adas Cabbage, IPM recommendation for fungicide timing and in almonds. Again, what you see, there are a range of frag groups that are available, and again, if you have a good coverage for anything like scab, shoal or eventually rust at these 3 timings, pedal full 2 weeks and 5 weeks, specifically with product within the group 7, frag group 7, 11, M3, Zyromancozeb, and M4 Captain. These were some of the product that worked the best from work in Spain, and eventually some chemistry from the frag 3 groups. Okay, so 3 timings here that are critical, and a list of frag group products that are important. So from there, I'll move to my last portion of the talk. I wanted to talk about bacterial blast. There are years where it can be quite a bit of a problem. You guys remember past years, but it's part of a complex disease, a complex system, because the same pathogen, the Pseudomonas bacteria, can cause the blast in flowers, also affecting the leaves. But there are cases, significant severe cases, where you can actually kill buds, and these buds will fail to push in the spring. And then there's finally another phase where you have the same bacteria causing canker and gumming on the trunk. But particularly, I like to focus on blast. You guys all recall we have a highly susceptible cultivar here in California. And so we had widespread, sometimes statewide events of blast, and that was the year 2018, 2019, 2020, and 2021. And basically not just almond, but all prunus species were affected by blast. So the way a blast works is basically this bacteria, that's the causal agent, is also can trigger ice crystal formation. So basically, you allow for water to freeze at temperatures where it would normally remain liquid. So the bacteria basically is promoting the frost within an orchard, leading to this severe blast occurrence. And so just a few words here to stay in the context of eventually disease emergence and so on, but this is just an illustration of the type of research we have done in collaboration with the Almond board. But this old disease like blast, last time he was studied was probably in the 90s, 1994. I think this was a good disease, or a good illustration here, where sometimes it's important to revisit what are the main pathogens. We tend to think we know, but again, the dynamic of pathogen prevalence can change in orchards. So we looked at the diversity of Pseudomonas bacteria that was affected with almonds, and then we understood that not only Pseudomonas syringae is out there, but there's at least another 2 species also potentially involved within this Pseudomonas disease complex. And here it's kind of interesting, again, just to maybe eventually do some work for risk prediction, disease emergence prediction, and so on. Within the multiple bacteria that we detected from almond, this was some pathogen study that we did for canker in November. And in this trial, mainly Pseudomonas syringae seems to be pathogenic to almond. However, if we repeat the same pathogeny study in the spring when temperatures are warmer, we can see that these other sort of new pathogens also are capable of causing disease within almonds. So this is just to say, or keep in mind it's very good to eventually once in a while revise those diseases, be aware of the diversity of pathogen, as any change in climate pattern, any change in weather could always lead to potentially the emergence of one versus another, depending of our environmental conditions here. For Pseudomonas also, we wanted to know, some growers love to spray copper for bacterial disease management, but the work we did here was to, assess. We know copper is a potentially good product for Pseudomonas bacteria, but Jim Adoskavich also came up with casugamycin, right, or cassumin product. And so we wanted to determine what's the percentage of our bacterial population in California that are resistant to copper. And from our study, we discovered that anywhere within orchard, anywhere between 50 to 80% of these Pseudomonas bacteria in orchards are actually resistant to copper. So that tells us copper will not exactly work good for disease management. On the other hand, we monitor this bacterial population for casugamycin susceptibility, and we could not detect isolates with susceptibility with tolerance to casugamycin. So these efforts are also really important in terms of, on the long run, managing disease. But our work as pathologists is sometimes also to look out at the susceptibility of the natural isolates of this disease, to again be at the forefront of resistant detection that could lead to new disease emergence. Okay, so with this, thank you all for being here, and the Almond Board of California for having supported some of this research. I'll be glad to take any question if there are any.